Okay, so
Is that Camtasia?
no, it's actually Snagit. Yeah, we're going to be recording this as well, so there'll be some fun changeover kind of in the middle of this. So, as you're probably all aware, all the major level browsers have development tools built into them. They kind of vary from good to IE. Um, uh, Personally, I use Chrome, the Chrome debugging tools. I've been using them as my primary dev tools for quite a while now. They're the ones that I think are the best of the ones that are available in all the different browsers. They've all got pretty similar features though within them. So like the primary features of the different dev tools is you've got something like an Elements tab, or it might be called HTML in the other browsers or something like that. Essentially, that represents a live view of your DOM. So from here, you can drill down into the different elements as you hover over them. You get some pretty colors on the HTML above it. Nothing particularly exciting about that at the moment, but yeah, ultimately this is kind of standard across all the different browsers. All the browsers also have a network tab, which if I just reload this page, we'll see some stuff in there. So what it's doing is it's showing all the stuff that we've downloaded in the browser. There's other tools that you can use outside the browser, such as Fiddler, if you're looking for this kind of information. And this is good for just kind of checking network performance statistics, what is and isn't coming out of the cache, why things say erroring, like what 404s, if you're getting any of those and stuff like that. Chrome actually combines its CSS and JavaScript, if you want to view those files, into a single sources tab. They changed this about a half dozen versions ago. Firebug and the IE dev tools still keep them separate, so you have a CSS tab and a scripts tab or a JavaScript tab, and that's where you would say do your JavaScript debugging or anything like that. As I said, Chrome has it just all combined into one, although I'm not really sure if you're ever going to be doing CSS debugging using the sources tab, but I think the debugging stuff is actually enabled there. And the last one that's kind of common across all the browsers is the console. The console is basically just somewhere that you can execute arbitrary bits of JavaScript. I think it actually came in the IE7 DevTools, had an initial very basic console. It's slowly evolved over time. IE has an okay one, but one of the major problems with the IE one, which is why I prefer Chrome and Firebug if that's my only other choice, is that when you say have an object that you want to inspect in Chrome, you actually get to inspect the object. So if I just do like window, so I can actually inspect the object. A lot of the, particularly the older IE, so prior to IE10, would just output objects, square brackets, object. So it would do a toString on it. Like if you just did toString in a .NET application and just output that to a console window or the debug trace. IE10 is slightly better at that. It'll show you the first half dozen properties and then ask if you want to add it to the watch window. Still kind of crappy because it means that you've got this kind of break-in flow. You can't just dump stuff out inside of the console, which is just a full JavaScript environment where you can execute as much code as you want. I'm not 100% sure about Chrome, but I know that Firefox and IE allow you to do multi-line mode. I don't use that a whole lot, but it allows you to say if you want to execute multiple statements, you can kind of expand that out into a multi-line mode and get down and execute multiple statements and then have them all output rather than just trying to break them up over multiple lines or shift entering and not accidentally executing your code. This little Snagit thing is really quite in the wrong place. No, doesn't want to move. That's really annoying because there's a really cool little icon underneath it that I wanted to show. So we're going to have to do something like this. So down in the bottom right corner of Chrome, this is the thing that most people will kind of overlook because it's really hidden out of the way. It's where the settings for the DevTools are. And there's some really cool things that you can do from this. First of all, there's user agent overriding. I'm going to look at that in a bit more detail a bit later on. look at some mobile stuff. But both Chrome and IE have built-in user agent overriding. IE also has the ability to simulate itself fully as the older browsers. So IE 10 can go all the way back to, I think, IE 7 from basically a rendering engine and JavaScript engine, not just a user agent point of view. Chrome also has some other advantages. Like if you've got a widescreen monitor, you can actually dock the DevTools to the right, which is on a widescreen monitor a whole lot better than just having these huge DevTools across the bottom and this tiny little window that you're playing with. If you've got like a 24-inch screen, you probably don't need a browser that's 1900 by 1080. So you can shove that to the right, and it gives you plenty of space to kind of view both things at the same time. If you're doing a lot of dev stuff in the browser, say changing CSS and JavaScript quite frequently, and you're wanting to see how that works, make sure you disable the cache. This is kind of a hidden setting in Chrome. It's through the settings tab here. And what that'll do is every time you do a GET request for CSS, JavaScript, anything like that, it will always get a new version from the server. It will ignore any cached versions of itself. And this can be really useful, particularly if you're, say, testing against a environment beyond your dev machine that might be output caching results. It's really frustrating if you're like, well, why isn't this changing or anything like that? In IE, you've got to go into the settings and then you change how it will download the files. So let's wait for IE to respond. There we go. Internet options, and then under settings, there's every time I visit a web page, that will always get new versions of the file, so it will ignore cache. So you can turn that on in both browsers. I'm not 100% sure about Firefox. I haven't spent enough time in the DevTools or in Firefox itself to work out how to do that. Disabling JavaScript, that's going to make my demos really boring if I do that, so I'm not going to. And then there's just a whole bunch of other things that you can change with inside Chrome to the way that the DevTools work. Another really cool thing about the Chrome DevTools is they've got a whole bunch of keyboard shortcuts. So just navigating between the panels is a simple example of something that you can do from the keyboard rather than having to mouse around. I'm very much a keyboard fan. If I have to move to the mouse, it just annoys me. So I like the fact that I can just navigate around straight from the keyboard. And Chrome also has a couple of other really interesting features in the way that it will interact with the elements panel. So if we come to the elements and say find some, let me just dock this again. So let's just inspect a particular button here. So I've got this button down the bottom that I've inspected, and from the console I actually want to do some stuff with that. Control L will clear the console, so if you've got a lot of debugging messages or anything like that, Control L is a great handy keyboard shortcut to use. But $0, so I can actually zoom that in. Excellent, I thought I could. $0, that is the currently selected element in the elements panel. So this is really useful if you're wanting to write a little bit of jQuery against that. I want to manipulate that with jQuery. I want to add some classes, I want to remove some classes. $0 gives you that DOM element, so I can do $$0, and that's a jQuery version of that. So I could then do add class of foo, and then you'll see that my element now has a foo class and a $0 foo. So that's a really kind of not obvious little shortcut, $0 to get back to the current element. I think $1 is the previously clicked on element. So if you've been clicking around the DOM in the elements panel, you can use $1 to go back. I think it keeps going down a numerical hierarchy. So the more you click around, the more dollars number you're going to have. So you can go back to the different elements that you've been interacting with inside your elements panel. All right. Another really useful tab that I don't believe any of the other browsers are implementing yet is this resources tab. So in How cool is that? Actually zooms in as well. So in Chrome, you can use the Resources tab. It will allow you to inspect a whole bunch of things from the files that have come down. Oops. Let me just make this a little bit bigger. So you can have a look at, if you're using iframes and stuff like that, you can actually inspect the different frames and what content was served out by each one, and view the requests, see what the response was that came back, HTML, CSS, etc. Or if you say you're using cookies on your website, this is where the cookie view is. I know there's Firebug plugins that will also do this. I'm not sure about IE. I think you kind of have to just deal with the console in the IE DevTools. There's no great way to view the cookies. But then if you start using some more of the HTML5-ish features, so you're using, say, local storage. This sample application that I'm running here is a single page application from a Pluralsight training course. And what it's doing here is it's actually pushing some information about what has happened in the page state. So I think Tatham's last one was on single page applications, or no? No, I think
Real-time apps.
Real-time apps are. Yeah. So
Before that, we did offline, where we did local storage.
That's it. I knew you did one on them. So if you're if you were at the offline applications one, Tatham would have talked about the local storage, and this is just a way that you can kind of store things that are a bit more advanced than cookies. Cookies have a bit of a limitation on what you can kind of store within them. Local storage allows you to kind of go a little bit further with that. It's a key value pair store that you have here. This application is just using a little library that wraps around that. But what's interesting about this is from the DevTools, I can actually inspect what my application is trying to store on my behalf inside of itself. And no other browser's DevTools that I know of has this kind of feature built into it. If you're working with offline applications and you're, say, using the app manifest file and you're storing stuff properly offline with that, you can also inspect the application cache through that within here. See what actually got cached, remove items, stuff like that. So while I was just doing a full audit of what was available in all the DevTools, F12 is how you open up the DevTools in all the browsers. I'm pretty sure it's the same in Firefox, but Chrome and IE, I know it's F12. One thing that I did find quite interesting while I was diving around and just, as I said, doing a full audit of all the features that were available in all the different DevTools is IE has some really bizarre options. It has a color picker. If it wants to fire up. This demo would have been a whole lot cooler if it hadn't taken forever. But yeah, there's actually a color picker control that will pop up from the IE DevTools. So if you're, say, wanting to steal a color scheme from the site, you can actually use that rather than going out and finding a plugin for Firefox or Chrome or anything like that. There's also a ruler. The ruler is quite useful if you're... Oh, there we go. There's our color picker. So that's white, everyone. Let's go to Google and color pick. There we go. That's one of the blues part of the Google. So that can be useful if you're doing a lot of CSS work, or you're trying to get inspiration from existing websites, find out what their color scheme is to blatantly rip off. The other one is the ruler. Whoops, tools. Ruler. This can be useful for particularly when you're working out measurements of like how big elements are on screen, what padding you've got applied, and if the DevTools it can be kind of annoying to some in some of the DevTools, particularly in IEs, to actually see where elements start and finish and what the gaps is in between them. The ruler is less useful now that IE 10 actually has some reasonably decent DevTools in it. It was a lot more useful in the older IE DevTools because they just sucked. Chrome also has a bit of a ruler. It's going to be kind of hard to see on this screen, but on the across the top and down the sides, it actually shows you a ruler with pixels, and the element will let's just put that down. Inspect that. Yeah, it's not super easy to see, but we have a whole bunch of lines here that coming out from the element that shows where the padding is, where the margin is, and where the actual element height and width are, to show you whereabouts it lines up on screen. So you can, that's a good way that you can find overlaps between elements, between like margins and borders, or if you've got elements that are supposed to be floating next to each other, why isn't it floating next to each other? Oh, it's actually got a padding. The padding is coming out a lot further than I thought, or anything like that. All right, let's have a look at some JavaScript debugging. I've been using Visual Studio for no idea how long, but it's taught me one thing, and that debugging is really, really important, and having a good debugging experience is really vital. The DevTools in all three major browsers are actually starting to catch up to almost what kind of a debugging experience I've had from Visual Studio for a number of years. They all have the ability to set breakpoints. Chrome has a really good call stack window, and the ability to kind of walk back up the stack when you've got breakpoints hit. And another thing that I often forget that the different DevTools have is they can set conditional breakpoints. So from Chrome, if you come down and set a breakpoint and then choose Edit Breakpoint, you can set something conditionally, like you can in Visual Studio for a breakpoint, and that can be really good if you're only interested about, only interested about a particular scenario that you're trying to hit within inside of your debugging. So let's see if I can remember where the code is for that. No, I can't. One thing about the DevTools is they can be a little bit flaky about remembering what you are and aren't doing, particularly the Chrome ones, because the Chrome ones are actually written in HTML. So they, as you saw there, like the condition window didn't just immediately go away. That it's kind of a common scenario across all the different browsers DevTools. Now, one thing to note with the IE DevTools, it will always pop the IE DevTools into a new window if you're using the script debugging. That's because it actually runs in a different process when it's doing the script debugging. They can't seem to work out how to run it in the same process of IE. Yeah?
Because JavaScript runs in the same thread as the UI, and
yes.
if you have a breakpoint that you're paused on, then the UI thread is paused, so you wouldn't be able to click the DevTools to be able to resume execution. Yeah. So they have to split it in a separate process in their process model for you to actually be able to debug and pause and still use the UI, because they haven't plotted it all through.
Yeah.
They haven't justified the need for that.
Yeah. It's only a problem in IE. All the other DevTools seem to do it fine. Again, it's not like I'm bagging IE or anything today. All right, so let's just see if I can set a breakpoint on that. Actually, I was 100% sure where that. Oh, anyway, say you don't know where the JavaScript is for a particular breakpoint that you want to set. Like, I want to set a breakpoint on the click of that refresh button, but I'm not 100% sure where that JavaScript is, or I'm running in a minified version or something like that, or I'm just not really sure what event handlers are even wired up. In the Chrome DevTools, I'm going to have to pop this out into a new window, I think. Oh no. In Chrome, we can actually inspect the event listeners. So if I pop that into a new window, you'll see here for the button that I've got clicked, this has a tab that I've expanded here. I've got to click a mouse down, a key press, key down, key up, and then a couple other event listeners that are on there. So that's kind of cool, and these are all inspected both out of jQuery and straight on the DOM. These have been set mostly through jQuery, as you can see. The problem is that, well, if I kind of come down here, I don't really have much of a useful thing. It's like I don't really know what. That's not really useful. Like, what's it? What event is it listening to? It doesn't. So I have this listener body. Well, I guess there's the code. Now I can go back into my dev tools. I can then search for that chunk of code and then chuck in a breakpoint. That can be kind of tedious. I'm just going to reload because I was doing this before. Okay. So instead, let's inspect my element again. So much better with big screen. There we go. Okay, so I've got my button again. Now if I come back and $0, so there's my button. $.data. So whenever jQuery registers an event handler, it goes onto the element into its data properties. So this is a combination of custom information that you could be putting against a DOM element or HTML5 data attributes. Both of them go into the same location. And you can access that from the element directly or through $.data. So in this case, because I've got the DOM element, I can do $.data, pass in the DOM element using $0, and then say events is the data property that I want back. And this is the jQuery event cache for that particular element. You see here, I've got a click handler, and come down, I've got an array of click handlers. I have currently one click handler, which is some kind of crazy thing, which is actually the minified jQuery source. That's the event handler that's going to ultimately be fired when I click on that button. So I want to make it so I can intercept that. I want to add my own breakpoint at that point, but I'm not 100% sure where it is. I don't want to dive through minified source or anything. So I could say via handler $.data, $0, events, click 0. So that handler is the function that will be executed. Now, instead of executing that function, I want to execute my own function. And so I want to execute my own function here, and I want to use it's a statement, I think, in JavaScript, which is specific for the language, called debugger. So this will tell any listening dev tool to initiate a breakpoint at that point. It's like in .NET where a debugger.break, if you set that in Visual Studio, you got your debugger attached, it will just kick off the debugger whenever that line of code is executed. There's a similar statement inside of JavaScript called debugger. And the next thing I want to do is execute my handler function that I previously captured, so it will execute the handler as before. This and arguments. Okay, so now I've attached my own debugger, so my own programmatically set breakpoint, and then I will click the refresh. You see that the DevTools have immediately stopped at this debugger line. You'll see that there's some information that have been wrapped around it from the Chrome DevTools itself. And then if I step in, I end up in that jQuery in, oh actually, sorry, this is Knockout, my bad. It's not actually from jQuery, it's from Knockout. So I've ended up inside of the handle that was originally going to execute. Now this isn't exactly a great debugging experience. I mean, this is kind of mangled source code. All the DevTools now support pretty print. So I can click that and it will reformat out the code in, just runs it through a beautifier, which is, it makes it obviously easier to debug. We don't get, obviously, the variable names or anything restored. That's a whole nother problem to be solved. But at least we don't have just like one line of JavaScript that we're just trying to debug through. So you can see over here on the, I'll pop this into a new window, make it bigger. So over here on the right hand side, you can see our call stack. So I came in through an anonymous function, that's where we currently are. there's the click handler that got overridden, but ultimately it came through a dispatched event with inside of jQuery, which, yeah, so we can bubble all the way back up to work out where this event actually came through. It ultimately started within jQuery, and now we're inside of Knockout. I can also see variables or objects that are available within inside the scope of where I currently am. So local means variables that are defined within the scope of this particular function. And then closures are things that have been captured through the outer functions. So I'm not 100% sure what we're going to find here, but we've got something called G, which is click. We've got elements that have obviously been found through higher versions of the closure scope, stuff like that. And that can be useful for debugging and working out, well, okay, here I am, what's available in my parent scope, and just kind of looking at all the data that could be available within inside of this function should it be required. Like Visual Studio, these have got keyboard shortcuts, F10 for step over, F11 for step in, but it's not F5 to continue. This is something that I see a lot of people get tripped up with. If you hit F5, you reload your browser. It's kind of ruined my breakpoint. Chrome, it's F8, is execute till the next breakpoint sort of thing. Not 100% sure about the other two browsers. I think IE is actually F5 because it is running in a separate process, so it isn't. You won't actually reload the browser. As for Firebug, I'm not 100% sure what that is. I only know Chrome because I only ever debug my JavaScript within inside of Chrome. So the next thing I wanted to touch on was how do you actually find out information about what's happening inside the current say function. You don't want to have to put a breakpoint every single time. You may want to just find out some information as the page is loading. So you'll see here we've got some information that's been debugged out from SammyJS, which is a library that's being used by this. That's through the console API that's available in all the top level browsers. Don't use alerts for debugging or outputting state. One of the primary problems with using alerts for doing that notification is it will lock the browser. While an alert is visible, you can't interact with anything else. The JavaScript in most browsers will be thread locked as well. So until that alert is dismissed, you won't have other things happening underneath. So it's a complete control break in your code. So you are now no longer executing your code in the same manner that it would normally be executing without those, say, debugging symbols enabled. The console object has Chrome is really useful and doesn't actually show me all the stuff that I wanted on there until we go into the prototype. So most people are probably familiar with console.log. That's just a generic logout statement. I just want to write some information out to this console window. But there's a lot more options that people kind of overlook. A lot of them are very similar to what we get from the .NET debug and trace APIs. So you've got things like console.assert. So if you want to make sure that, say, within inside of a function, the argument's getting passed in and matching some kind of a statement. So if I was to do a console.assert, this will take a boolean. So if I just do false, that will just bring up an error. So I'll have an error registered inside of my DevTools. So I can quickly see, oh, well, something failed. It wasn't actually a JavaScript execution problem. It was a code assumption problem that I've got, and then maybe write some tests to cover that scenario or delete the line because we don't want the red X's appearing or anything like that. Chrome has a few more interesting things, such as doing timer tracing. So you can basically, like the stopwatch API from .NET, so you can start up a stopwatch, execute some code, and then end it, and then see how long that took, which is really good if you're trying to profile and get like really high performance stuff, particularly if you're dealing with, say, mobile browsers or something that has to have good mobile support as well. So one problem with the console API is that if you put this into production, you're going to have just a whole bunch of kind of crap code or crap messages that might get logged out or anything like that. What I've done in the past is I've actually wrapped the console object inside of another little API similar to, say, a Log4Net API or nlog or anything like that you would use in .NET for just logging information out, wrap it away in JavaScript, and then on the dev version, just have it writing out to console, but in production, say hitting a web service or a web API backend or something like that, so that if an error happens, you can just log that information straight out to a web service, capture that, and the user is kind of none the wiser. They don't have messages populating out, but you still are able to capture all of that useful information. The debugger statement, make sure you don't put that into production code, because if anyone has the DevTools open, it will breakpoint on their DevTools. Some of the older versions of Chrome, and I'm pretty sure IE, I think all versions of IE, will actually kick off and ask them to attach a debugger, regardless of whether they know what a debugger is. So, what we did on a previous project was use a JavaScript static analyzer, JSLint, I think we were using. You use JSLint or JSHint, and just looking for anyone that was anyone to check code in with a debugger statement would actually break the build. So that's a good way to kind of get around that problem, making sure people don't do some of that stuff that you don't really want them to do. So I've got going to be running out of time pretty quickly, so I just want to show off a couple of really cool features. So I said that the DevTools have user agent overriding. So if we say with Chrome, we'll tell it to be iOS 4 for iPhone. So if I reload, that immediately forces my browser to think that it's iPhone. Chrome does a really nice thing. It will actually shrink the screen to what a standard width is for that, say, mobile user agent. And I've hit the smh.com.au, and it's immediately detected the mobile stuff and then redirected that into a mobile view. This can be really useful if you're doing mobile work and you say you don't have a myriad of phones to play with, and you just, well, I need to see, well, am I at least going to the mobile website? Do I have that happening? What's the basic look going to be in a mobile website before I put it onto a phone? Because trying to debug on a phone can be a whole lot more problematic. So user agent overriding, IE10 actually has a really good list of user agents built in. It has IE for Xbox. I found that the other day. I was like, cool. I'm not sure I'm going to be building websites for IE for Xbox, but yeah, it's going to be there. But it's also got a whole bunch of the Windows Phone user agents already set up. Chrome has a good list of user agents as well, and both of them allow you to define your own user agents. So if you want to say iOS 3, which is no longer, it's not in these lists, you could chuck in the iOS 3 user agent and make sure that's also being detected. It will stay inside that user agent while the DevTools are open as well. So yeah, that's another thing to kind of keep in mind. There we go. Oh, no, SMH has redirected me to a different domain. Okay, so that's cool. If you want to do some mobile stuff, you can obviously flick user agents, but you're still kind of simulating the mobile browser inside of Chrome. For iOS, this is not really going to work. Mobile Safari isn't the same as Chrome 22. There's quite a few differences between those two browsers, and all you're getting is user agent simulations. To actually debug remotely on the phone is a little bit tricky, but the PhoneGap team have developed a really useful tool for doing it. The tool's called Wiener, W-E-I-N-R-E, and the way you get that, it's a Node.js package, so you need to use Node to install that. They've got all the instructions on their website. But I've got that already installed on my machine. I'm just going to kick it off, and it starts up a web server at localhost 8080. So if we go localhost 8080. So, okay, so that's what Wiener stands for, Web Inspector Remote. I think that they just thought the name Wiener was cool and then had to work out an anagram that was kind of working for them. It's not great. So what this is doing, this is running a little web server that serves out a piece of JavaScript that you want to embed inside of your remote page. I'm just going to do this kind of all on this one machine because I don't want to have everyone trying to stand around and watch me play with my iPhone. It's going to get kind of crowded. So yeah, you can either embed this script tag up here, which will be appointed to your machine, or you can just execute this piece of JavaScript. Grab that. So let's come into here, close that off. Let's debug SMH. So just executed that bit of code, and now I want to log into the actual Wiener inspector. I have to have this across a couple of things. No, don't want that one. There we go. Okay. Now, elements. Okay, so what Wiener does is it uses the Chrome DevTools, because remember I said the Chrome DevTools are actually HTML, so it bootstraps them into its little web server that's running, and then it creates this remote view of your DOM. So this is the DOM for SMH. This is the live DOM. So as I'm, say, clicking around on here, that's actually going to have broken because the JavaScript is no longer on that page. Let's just re-execute that. Just reload Wiener. Okay. So that's the DOM here. I can inspect the styles. Let's just come down and see if I can find some actual part of the HTML on the page. Most viewed, nope. So you do have some limitation with this. The inspector doesn't work, so I can't just inspect an element. Kind of, that's going to be really hard to do on a when you're actually debugging on a device. Okay, so here we go. This is the breadcrumb that I can say inspect. The styles can be a little bit flaky as to whether or not they get picked up, because it's got to read that out of the DOM. It's obviously not picking that stuff up for me at the moment, but I could go background color. There we go. I've just made the home icon a whole lot more badass. There is actually BADA55 is badass, and it's a valid color. If you take nothing else out of today, that's how you make your sites badass. You have a JavaScript console, so I can do alert, hello world, kicks off an alert. So that actually sends it over to the remote browser, executes that JavaScript on the remote browser. So if you're on your iDevice or your iPad or your phone 7 or your Droid or anything like that, you can send JavaScript over to it to execute, read responses out. You can pretty much do nearly anything that you want. $0 still works. So a lot of the things that you get from a full Chrome level debugging experience, you do actually get here. The timeline and networking stuff is not 100% working because it has to wait until that initial bit of JavaScript gets loaded, but it can intercept AJAX requests from memory. You don't get script debugging. That's kind of the one feature that you don't get, because that's more of the browser has to dictate that, so you can't debug scripts, which is a bit of a pain, but that's where I guess the console object will kind of take over and allow you to do that kind of debugging. The last thing that I want to touch on, if I have a few minutes, is so some of you might have heard about the new something to JavaScript Compiler that Microsoft released last week called TypeScript, or you might be familiar with CoffeeScript. They're ways that you can use a different language to write JavaScript. The problem with those is you end up debugging something that is written in that is JavaScript, but that's not the code that you initially wrote. You also have the same problem if you're using a minification library. So you deploy into your test environment, you've put your minifier through your JavaScript through a minifier. The code that is now deployed is not the code you initially wrote. So debugging that can be a lot trickier. I'm going to have to use Chrome Canary, because this is it's a new feature that's coming in the browsers. It hasn't actually dropped into anything other than Chrome Canary at the moment. I think the Firefox team is working on it, but it's a feature called source maps. Source maps are for JavaScript what PDBs are for .NET code. They're essentially a mapping between the code that you wrote and the code that you're debugging, which is, and they're really, really powerful. So I'm just going to jump into a simple little demo. Let's go here and source map, and then okay. Oops. TS. There we go. All right. So what I've got here is I've got a little TypeScript application that I wrote. It's just a basic little pub sub library, but what you'll see here, I mean, it kind of looks like JavaScript, but at the same time it doesn't actually look like JavaScript. There's things in there, there's interfaces, there's classes. Well, actually, there's no classes in this, there's modules, stuff like that. So that's not actually JavaScript. So I'm not going to be debugging that in my actual code. So this is the code that I end up from JavaScript. It looks somewhat similar, but at the same time, it's same but different. So obviously, I'm going to have to run that JavaScript inside of the browser, which is a bit of a pain. Just attach this, but because I wrote this in another language, how do I debug that? And that's what source maps does. So if I come to my JavaScript file here and chuck a breakpoint there, hopefully there we go. That gets hit, and then nope, damn it, I breakpointed in the wrong file. Did it come out? No. One last crack at seeing if I can get this to work. Otherwise, I will give up and we will go over to Tatham's demo. Yep. So inside the settings in the Chrome Canary DevTools, there's this Enable Source Maps option. So if we enable that, just reload my page. You'll see now here I have a .ts file. So that's the initial TypeScript that I wrote. If you wrote this in CoffeeScript, you would have, say, a .coffee file. If you were running this through a JavaScript minifier, Uglify.js is one of the minifiers that currently supports this. You would have another .js file, which is your uncompressed version. And okay, so I've set a breakpoint. I've set a breakpoint inside of something that is, so I set a breakpoint in something that wasn't actually, no, I was supposed to set a breakpoint in something that wasn't actually JavaScript. Come on. Anyway, my demo has failed. We will move on, but this is something really to watch out for in the next kind of 6 to 12 months. That I would expect that more of the minifiers, at least, will start supporting this concept. That, well, I don't want to be debugging minified JavaScript on my production system, but if I can generate what's essentially a PDB file for JavaScript, I'm going to be able to debug the code that I initially wrote through on an environment that I don't necessarily own, which I think is really quite powerful. That demo would have been a whole lot cooler if it had worked, but unfortunately it didn't. You just have to take my word that it does work, or read the blog post that I wrote. I'm going to hand over to Tatham now, and he's going to talk about other stuff and IE6.
No, IE6. Yours fine.
All right.